In this session, let us see energy stored in a magnetically coupled inductor, and let us try to develop some models. Okay, 2-3 models we are going to develop. I repeat, it's meant for magnetically coupled inductors only. It is not meant for ideal transform, because electrical guys, the moment they see this kind of diagram, people feel that it's ideal transformer. Okay, I'll tell you, ideal transformer means coefficient of coupling should be K equal to 1. In the sense, whatever the flux developed here, the total flux is going to link here. There will not be any kind of leakage. That is ideal transformer. In the next session, we are going to discuss about the ideal transformer. Now, if I think of magnetically coupled, in the sense K is less than 1. Okay, so out of the total flux produced here, some portion of the flux will go to here, and the remaining portion of the flux is going to circulate here only. Basically, I am saying this because some faculties are saying this T model. For example, we are about to develop a T model in this particular session. The T model means some faculties are saying it is meant for ideal transformer. No, it is not ideal transformer. Okay, in ideal transformer case, what will happen? In the next session, we will see. Okay, let us think energy stored. Let me think of only one inductor. Okay, so in this inductor, if I have current I, okay, so if I think of I1, okay, you know right hand thumb rule, so current flowing is in this direction, so operating flux will be in this direction, which is pi 1. Now, if this current is time varying, flux is going to be time varying, so because of that, some voltage will be induced. Let me write V11. Okay, so how much is that V11? V1 equal to L1 di1 by dt. Okay, so just a minute. So let me calculate power. What is power? Power is going to be V11 into I1. Is it power absorbed or power delivered? Power absorbed, because my current is entering into positive terminal of voltage. Okay, now it means if I integrate it with respect to dt, it will give you energy. Okay, so how much is energy now? This is going to be L1 di1 by dt into I1. Okay, let me write I1 before. Okay, I1 dt integration. Dt will get cancelled. I1 di1 integration is going to be I1 square by 2. So this is half L1 I1 square is going to be energy stored. Now let us think of for this inductor. Okay, so it is same. Let me think of I2 is entering here. Okay, if I2 is entering here, you know right hand thumb rule. Okay, so flux is going to be in downward direction. So this is pi 2. Induced voltage, self inductance only. No, let me think of V22. Okay, so because of current variation at the entry of the current, I am keeping the plus. So V22 into I2 is going to be power absorbed. So what is power absorbed is going to be V22 into I2. If I integrate this, I am going to get energy stored. That is going to be half L2 I2 square, if I think of this as L2. Okay, now let me have combined effect. Okay, let me have combined effect. So see here, let us think of my current is entering here I1. Okay, so because of that, my flux lines will be in this direction. So pi 1 is going to be in this direction. So because of that, I got some induced voltage of V11. Okay, if current is entering in this direction, so again my current is entering in this direction, so flux is going to be in downward direction pi 2. So if I don't have this, under that condition, induced voltage is going to be V22. Okay, now if I see magnetically coupled, meaning that because of this current, because of this flux, some voltage will be induced here. Okay, so that induced voltage is going to be plus minus V12. Okay, now because one thing, pi 1 and pi 2 are aiding or not? Yes. So the moment pi 1 and pi 2 are aiding, we have been discussing the same. Means ultimately my induced voltage should be increased. Okay, here also without having pi 2, I got V22 because of pi 1. Sorry, without having pi 1. Okay, by having only pi 2, I got V22. Now because of pi 1, what is the net flux is increased, so net induced voltage should be increased. So plus here minus here, this is V21. Okay, now if you observe the power absorbed here, okay, about V11 into I1 already we calculated. Now about V12 into I1 means the moment voltage is increased here, current is same. For example, if I think of these currents are current sources. Okay, so I1 and I2 are current sources if I consider. Under that condition, because of this I2 voltage is increased here, so power absorbed will be increased. Okay, now if I think of I2 is current source, so because of I1 voltage is increased here, so the moment voltage is increased for the same current, I am going to get more power absorbed. That particular power absorbed will be stored here. Okay, now if I say this particular extra one, okay, so that extra power, if I see, this is V12 into I1. Okay, this is extra power because of mutual, and here plus V21 into I2. Okay, so this is going to be M di2 by dt, because induced voltage here because of this current is going to be di2 by dt into I1 plus V21 is going to be M di1 by dt into I2. Okay, now if I integrate this, I am going to get energy. Okay, so see here dt. Okay, so this is going to be M into I1 di2 plus I2 di1 integration. Okay, already we know UV formula plus 2. Okay, so plus 2 or plus 1 UV formula, integration formula we know, so that is going to be M into I1 I2. Okay, so altogether what is the total energy stored? What is the total energy stored? Total energy stored is going to be half L1 I1 square plus half L2 I2 square plus M I1 I2. Okay, now let us see the diagram again. Okay, see here energy stored, if you see, if pi 2 is aiding pi 1, under that condition net flux is going to be, see here, if pi 2 is aiding pi 1, net voltage is going to be increased. Under that condition, increased voltage, same current, power absorbed is going to be increased, such that in my magnetically coupled network, in the magnetic field, energy stored will be increased. If I think of my current is in this direction, maybe let me take black. Okay, if current is in this direction, then what will happen? My flux is going to be in opposite direction. Okay, so if my flux is in opposite direction, what is the net flux is going to be reduced? Net induced voltage is going to be reduced, so it will be reverted. If net induced voltage is reduced for the same current, voltage is reduced, so power absorbed is going to be reduced. So energy stored is going to be reduced. So this has to become plus or minus. Okay, so you please take this half L1 I1 square plus half L2 I2 square plus or minus M I1 I2, plus or minus will be decided by the whether the fluxes are aiding or opposing. Okay, now let us try to develop a model for this. Okay, so if I try to develop a model, what are the equations we are getting here? Okay, so here induced voltage, if you see, that's fine. Here induced voltage, if you see, basically with as dependent sources. Okay, mutually induced voltages can be shown as dependent sources, and these dependent sources are very much important to me, because in future we are going to discuss about superposition theorem or maybe Thevenin's theorem. There, why this particular dependent sources cannot be killed, cannot be deactivated completely, but independent sources can be deactivated. Why dependent sources cannot be deactivated, you will come to know there. Okay, so that's why let me develop the model with dependent sources first. Okay, in future I will tell you the advantage of this. So what is the total induced voltage here? If I think of total induced voltage plus minus here V1, just a minute, plus minus here V1. Okay, so minus of V1, okay, minus of V1 or V1 equal to plus V11 plus V12. Okay, so this is going to be equal to L1 di1 by dt plus M di2 by dt. Okay, because total is going to be in aiding direction. Now if I think of here, for example, if I think of plus here minus here, V2 is the total induced voltage, so minus of V2 or V2 equal to plus V21 plus V22. Okay, so V2 is going to be L2 di2 by dt plus M di1 by dt. So these are the equations which should be satisfied by the model, mathematical model. Okay, so let me draw here. this is V1 and this is I1 and this is L1, okay, and plus minus this is going to be M di2 by dt. Okay, so such that minus of V1 or V1 equal to L1 di1 by dt plus M di2 by dt. Now let us try to develop the model for second coil. Okay, for the second coil, again this plus minus M di1 by dt, and this is L2, this is I2, this is plus minus V2. Okay, so equations are going to be satisfied here or not? Minus V2 or V2 equal to L2 di2 by dt plus M di1 by dt. Okay, now if I go ahead with the dot convention, okay, if I go ahead with dot convention, see here, if I go ahead with the dot convention, where we have to keep the dots, already we discussed a lot about dots and all. So if I keep one dot here, another dot should be here. Okay, if both currents are entering into dots, net flux is going to be increased, net induced voltage has to be increased. So that is going to be the model with dependent sources. Now let us try to develop T model for this. Okay, if I try to develop T model, okay, of course we can do reverse engineering. Okay, we can add some terms, we can remove some terms, such that ultimately these two equations has to be satisfied. Okay, so see, again let me repeat, this T model is not meant for ideal transform. I repeat, T model is not meant for ideal transform. In ideal transform we will see how to calculate and all. So this is L1 minus M, this is L2 minus M, this is plus M. So this is I1, this is V1, and this is I2, this is V2. Okay, if I write the equations here, the same equation should come, then I can consider this as a model, mathematical model. So if I write the equation here, what is happening? Minus V1 or V1 equal to L1 minus M into di1 by dt plus M d by dt of, see here, I1 is entering, I2 is entering, so this is going to be I1 plus I2. So I1 plus I2. Now if you see, what are the things that can be cancelled out? See here, minus M di1 by dt plus M di1 by dt, these two will be cancelled. So you got the same equation or not? L1 di1 by dt plus M di2 by dt, same equations. Now let us try to develop here. If I write equation, okay, minus of V2 or V2 equal to L2 minus M di2 by dt plus M d by dt of I1 plus I2. Okay, so L2 minus M di2 by dt plus M I1 plus I2. Okay, now what are the things that can be cancelled here? See, minus M di2 by dt plus M di2 by dt. Okay, same equation we got it or not? L2 di2 by dt plus M di1 by dt. Okay, so this is going to be the T model in aiding condition. In this sense, pi 2 and pi 1 are aiding, or else I can say if both currents are entering into the dots. Okay, if both currents are entering into the dots, I can consider this as a model, or I can consider this as a model. Okay, so this is going to be dependent source. Okay, I can consider this as a model. If it is opposing, okay, if pi 2 and pi 1 are opposing, under that conditions what will happen? Let us see. Okay, if I2 is entering, I1 is entering here. Okay, if I2 is entering here, means here if you observe, my phase sequence is reversed. Sorry, not phase sequence, sense of the winding is reversed, direction of the winding is reversed. Okay, so if I1 is here, right hand thumb rule, my pi 1 is going to be here. If I think of I2 here, it is winding is like this, so pi 2 is in this direction. Both are opposing or not? Yes. So if I try to keep the self-induced voltage and mutually induced voltages, means my current is entering plus minus V11. Now because of this current, because of this flux, as this flux is going in opposite direction with respect to pi 1, net flux is going to be reduced, so net induced voltage has to be reduced. So okay, now if I think of here, current is entering here plus minus self-induced. Okay, in a passive element, always current should enter into the positive terminal of the voltage, such that this voltage into current will give you power absorbed. Okay, now after that, means if current is here, voltage is going to be here and flux is going to be in this direction. Now because of this current, because of this flux, net flux is reduced. Okay, in the sense net induced voltage has to be reduced, meaning that my voltage created here should be V21. Okay, so for this we have to write the model. Okay, so if I write the equations first here, if I think of total voltage here is V1. Okay, so minus of V1 or V1 equal to plus V11 minus V12. So V1 is going to be V11 minus V12. What is V11 self? L di1 by dt. What is V12 minus M? di2 by dt. Okay, so these equations has to be satisfied by our model. That's it. Okay, if I think of here, if I say total voltage here is V2. Okay, minus of V2 or V2 equal to V22 minus V21. Okay, so V2 should be equal to V22 self L2 di2 by dt minus M di1 by dt. Okay, so L2 di2 by dt minus M di2 by dt. Okay, so our model should be able to satisfy these conditions. If I try to develop the T model for this, okay, so T model, see, okay, means of course directly we can take this and we can add sometimes, we can remove sometimes, and we can make it happen. Anyway, we are engineers, we can do reverse engineering also. So this is going to be minus M, this is L1 plus M, this is L2 plus M, this is I2, this is I1, V1, V2. Write the equations, it will satisfy. Okay, let me write for one at least. V1 equal to L1 plus M di1 by dt minus M. Okay, I1 is entering here, I2 is entering here, so I1 plus I2 should enter here. Okay, so minus M into d by dt of I1 plus I2. Okay, what are the things that can be cancelled out if you see here? Okay, so plus M di1 by dt minus M di1 by dt cancel. Same equation, L1 di1 by dt minus M di2 by dt. Okay, so what is the conclusion here? If I keep minus M here, that is going to be opposing direction. If I keep plus M here, means it is going to be aiding direction. If I keep minus, it will become plus. If I keep plus, it will become minus. That's it. Okay, of course we can develop one more model. Okay, but we will try to develop that in ideal transformer or machines transformer. Okay, I don't want to confuse you people much. Okay, now anyway, in one of the GATE exam, they asked L equivalent. Okay, so let me calculate L equivalent. Okay, if I think of aiding direction, of course L equivalent they asked when second coil is short circuited. Okay, so this is L1 minus M, editing or opposing? Aiding. L2 minus M, this is plus M. Okay, so if I short circuit the secondary or second coil means he asked to find L equivalent here. Okay, so how much is L equivalent? Is going to be L2 minus M parallel with M. So means Z1 Z2 by Z1 plus Z2 in that way. So L2 minus M into M by L2 minus M plus M plus L1 minus M. Okay, so see here, this is going to minus M plus M will get cancelled. So this is L2M minus M square by L2. Okay, means if I extend this plus L1 L2 minus M L2. Okay, so L2M. Okay, so this is going to be L1 L2 minus M square by L2. Okay, or of course in the options given they did not give that way, they have given L1 minus M square by L2. Okay, maybe you may think of for aiding we got this, for opposing what we will get? For opposing also we will get the same. Okay, see here, for opposing, if I think of T model is going to be, this is plus M, okay, minus M L1 plus M, L2 plus M is going to be meant for opposing. Okay, let me calculate L equivalent across this after short circuiting this. Okay, same procedure, that is going to be L1 plus M plus L2 plus M into minus M divided by L2 plus M minus M. Okay, Z1 Z2 by Z1 plus Z2. Okay, so if you do this, you will get the same answer as L1 minus M square by L2. Okay, so point here is very simple. Whatever we analyzed here, everything is meant for mutually coupled inductors only, not for ideal transformer. Immediately after this, we will solve problems. In this problem, find coupling coefficient and find energy stored in coupled inductors at t equal to 1.5 seconds. Okay. In this problem, I am not going to follow dot conventions and all, especially passive element is connected. So if current is entering into undot, from undot current should come out. Okay, whatever we discussed previously. If current is entering into dot, current should leave from dot. All those things I am not going to consider when passive element is connected. Simply, I am going to consider here I1, I2, and this is given in time domain. So you have to convert that into frequency domain. What is omega here? Omega equal to 2 radians per second. Okay, so this can be 40 at an angle 0, and this is 4 ohms only. Okay, this is going to be minus 1 by omega c, j by omega c. This is going to be 8, means that it is going to be minus j4 ohms. And here this is 1 Henry, so this is going to be plus j2 ohms, because omega equal to 2. Okay, and here this is going to be 2 ohms only, and this is 1 Henry, omega L, 1 into 2 is going to be plus j2 ohms, and this is 2 Henry, so this is going to be plus j4 ohms omega L. Okay, j plus j omega L minus j by omega c, XL value, XC value already we know. Okay, so let us write equations directly, and now let us think of mutually induced voltages. See here, if current is entering into dot, other dot is going to be positive. I am writing this only for mutual, because self anyway we know. Okay, and current is entering into undot, dot is here, current is entering into undot, so here undot is going to be positive. If current is entering into dot, other dot is going to be positive. If current is entering into undot, other undot is going to be positive, that's it. Okay, now let us write the equations. So in writing the equation, 4 minus j4 plus j4 into I1 self. Okay, so this is 4 minus j4 plus j4 into I1. Okay, after that mutual, in applying KVL, I touch minus first. So minus, what is mutual is going to be j2 into I2. Okay, so j2 into I2 equal to how much? 40 at an angle 0. 40 at an angle 0. Okay, now let us write the second. J2, 2, if you think of self only, 2 plus j2. 2 plus j2 into I2. That is going to be self. And if you apply KVL in this direction, you are going to touch minus first. So, minus j2 into I1 is going to be 0. It is closed by its own. Okay. Now, if you convert this into matrix form, this is going to be plus j4 and minus j4 will be cancelled. 4 minus j2 minus j2, 2 plus j2 into I1, I2 equal to 40, 0. You are supposed to calculate I1 and I2. Okay, so in order to calculate I1, I2, 1 by AD minus BC. Okay, so 1 by AD, 4 into 2 plus J2, AD minus BC, minus into minus plus, J into J minus, minus of minus plus. Okay, 2 into 2 is going to be 4 into A minus B minus C D into 40, 0 is going to be I1, I2. Okay, so I calculated this. I got I1 as 7.8446 at an angle 11.31 and I2 is going to be 5.547 at an angle 56.31 degrees. Okay, so once this is done, you please convert this into time domain. Why we have to convert? Because at 1.5 second, how much should be the instantaneous value should be known, and after that half L1 I1 square plus half L2 I2 square plus or minus m I1 I2, we know the equation. We are going to find out the energy stored at that particular instant. Okay, so you please convert this into time domain. So instantaneous I1. Okay, so if you go back and see here 40 cos 2t. 40 cos 2t has been converted into 40 at an angle 0. So what is the phasor length here? 40 is going to be peak value. So whatever the values you got here, these values are also going to be peak values. So answer is going to be 7.8446 cos 2t plus 11.31 degrees. And I2 is going to be 5.547 cos 2t plus 56.31 degrees. Okay. Now for this you have to calculate I1 and I2 values at t equal to 1.5 seconds. Okay. So 2 into 1.5 will give you 3. That 3 we should not combine with degrees because it is in radians. Okay, so that radian should be converted into degrees because it is there in degrees. So 3 into degrees, 180 by pi. Okay, roughly 171, 172 degrees will come, plus 11.31 cos of that into this instantaneous values. If you consider I1 at t equal to 1.5 seconds. Okay, already I calculated that. I got minus 7.83 amperes, and I2 also instantaneous value at t equal to 1.5 seconds is going to be minus 3.689 amperes. Okay, so let us write the equation. In writing the equation, what is the equation? See here, energy stored at this instant. Energy stored is going to be half L1 I1 square plus half L2 I2 square m I1 I2. It can be plus or minus. If both currents are entering into dot, or if both currents are entering into undot, under that conditions we have to use plus, otherwise we have to use minus. So let us see. Now the dots and current directions I have said, I am going to see current is entering into undot, current is entering into dot. So one current is entering into dot, another current is leaving from the dot, plus or minus, minus. So we have to consider here minus. Okay, now all the what do you say equations, do you all the values you know or not? L1 is going to be 2 henries and L2 is going to be 1 henry, and mutual inductance is going to be given as 1 henry. So you please apply that. That is going to be half L12 into I1 at the second, minus 7.83, anyway square it will become plus half L2 is going to be 1 henry into I2 is going to be 3.689 square minus, how much is m is going to be 1 into I1 I2 7.83, because minus of minus is going to be plus only, no, 3.689. Okay, so if I calculate that, 39.22 joules, 39.22 joules. Okay, so we calculated, see here, 1 henry here, 2 henries here, and mutual coupling they have given 1 henry. Okay, so in this way we are going to calculate energy stored. Here in plus or minus m I1 into I2 means then only I considered whether my currents are both are entering into dot, or if one is entering into dot and another is leaving from the dot. Next thing is they also asked, okay, they also asked mutual coupling. Okay, so it is actually very easy to calculate mutual coupling. Okay, so what is m here is going to be k under root L1 L2. So coefficient of coupling they asked, so k equal to m divided by under root of L1 L2. M they have given 1 and 2 into 1 under root. 1 by root 2 is going to be 0.707. In the sense, coefficient of coupling is 70.7% or 0.707. Okay. In this problem, find V0. Okay, V0 is here. I am not bothered about the current directions. First I will take the current directions and later we will see. Okay, see here, let me think of like mesh analysis. Like mesh analysis, let me think of I1 here, I2 here. Okay, if I consider I1 here, I2 here, what is happening actually, when one current is entering into the dot, other current is also entering into the dot, actually not possible, like if you calculate only positive values. Okay, once one current is entering into the dot, this current should leave from the dot because you connected passive element here, But anyway, even if I take this way, I2 value can be negative. When I1 value is going to be positive, I2 value can be negative. Automatically mathematical equations will take care. We need not bother about it. Okay, so once if I calculate I2, what is V0? V0 is going to be 10 I2. Okay, so let us write equations here. Okay, so if I write equations here, minus 100 at an angle 45, if I send it to other side, 100 at an angle 45, 4 plus J8, so 4 plus J8 into I1, 4 plus J8 into I1, current is entering into dot. Okay, so current is entering into dot, so this dot is going to be positive. Current is entering into dot, so this dot is going to be positive. Okay, so in applying KVL, I touch it plus first. So this is going to be plus M J1 into I2 equal to 100 at an angle 45. Okay, basically these calculations you have to do using our normal scientific calculator only. Okay, means IS descriptive kind of. Now if I try to write the equation for this, self J5 10. So 10 plus J5 into I2. Current is, see here, current is entering into the dot, so this dot is going to be positive, and while applying KVL here, I am touching plus first. So plus J1 into I1 equal to 0. Okay, so convert this into matrix form, you can calculate. So this is 4 plus J8, J1, 10 plus J5, okay, into I1, I2 equal to 100 at an angle 45, 0. Okay, calculate 1 by AD minus BC, that relation. So this is 1 by AD 4 plus J8 into 10 plus J5 minus, okay, J into J is minus 1, J square is going to minus of minus plus 1 into A 4 plus J8 minus B minus C D into 100 at an angle 45, 0 is going to be I1, I2. Okay, directly I have to calculate I2 only. I1 I need not calculate because I2 multiplied by 10 is going to be V0. Okay, so let me calculate I2. If I calculate I2 means minus J1 into minus J1 into 100 at an angle 45, because this is anyway 0, minus J1 into 100 at an angle 45 divided by this is going to give you I2. So that I2 was is minus 0.7 minus J 0.714 amperes, or this is going to be 1 at an angle minus 134.43 degrees. And what is V0 is going to be 10 I2. So it's going to be 10 at an angle minus 134.43 degrees. Okay, so in this way we are going to calculate. Okay, so whatever the problems we solved in this session, both problems are magnetically coupled. It is not ideal transformer, because many times people feel that if two coils are shown adjacent to each other, people feel they are mutually coupled. It is not like that. Sorry, people feel they are ideal transformer. It is not like that. Okay, because if you calculate mutual inductance here, okay, for example, if I think of k equal to 1, if I think of k equal to 1, how much it should be if you calculate? Okay, so it means in ideal transformer k equal to 1. Okay, under that conditions m equal to k into under root of L1 L2. Okay, so 8 into 5 under root 8 into 5 under root 6.324. 6.324. If it is 6.324, if it is J 6.324, then only it will become ideal transformer. Okay, but it is J1 only, much less than that. In the sense, K value is going to be less than 1. Okay, it is not ideal transformer. It is mutually coupled inductors only. Okay.